In this example, we are going to sketch the following function, so this function right here, and state the key features and behaviors. So let's just remember that the key features are the vertical asymptote, the horizontal asymptote, the x-intercepts, and the y-intercepts. And the behaviors are going to be around what's happening at the end. So the end behaviors when x goes to positive or negative infinity, and what happens around the vertical asymptote. So let's start with the horizontal and vertical asymptotes. So, and I'll do that over here. So for the vertical asymptote, we're going to take the denominator here, which is x squared, and we're going to set it equal to 0, and we're going to solve. Well, all we have to do for this is square root both sides, leaving me with x equals 0 as my vertical asymptote. Okay, so let's take a look at a possible horizontal asymptote. This is where we're going to compare the degree of the top versus the degree of the bottom. So what's the degree of the numerator here? The degree is 3. So that's 3 there. The degree of the denominator is 2. So because the degree of the top is exactly 1 more than the degree of the bottom, that means we are going to actually have an oblique asymptote. Okay, and let's not forget the way we now have to solve for that oblique or slant asymptote. We are going to use long division and divide the denominator out of the numerator. So let's do that here. We're going to divide x squared out of my numerator, which is 2x3 minus x squared. But don't forget, we need a placeholder. So this is going to be plus 0x. We don't have an x value here, so we need to include a placeholder, plus 3. Now we are going to long divide, just like normal. So we are going to compare, I've only got one term here, and compare it to this and divide. So when I divide 2x cubed by x squared, that leaves me with, so that will leave us with 2x. When I multiply that 2x by this x squared, we're going to have 2x cubed, and we subtract. And as long as you've done this right, they will cancel, and they do. So let's bring down the next one. And then we bring down negative x squared, and we repeat that process. We take the x squared and the negative x squared here. So negative x squared divided by x squared leaves me with negative 1. So now we multiply negative x squared, subtract 0. And according to our process, we would now bring down the next one, 0x. But here's the deal. X divided by x squared leaves me with a negative exponent, doesn't it? Because that's 1 minus 2, right? So that would have left me with x to the negative 1. We can't have that. So we are actually done. And this right here is my oblique asymptote. My oblique asymptote is going to be y equals 2x minus 1. That is my oblique asymptote there. So let's plot both of those asymptotes on our little sketch over here. Okay. My first one for my vertical is that x equals 0. So that is right on the axis here. I will write just like that. I'll leave that as a solid line. I don't want to erase the background there, but that is my x equals 0. My next one is to plot my oblique asymptote, or my slant or diagonal line, right? We have to remember how to plot a line. So we start at my y-intercept, my -1, and then I use my slope, which is my rise over run, so 2 over 1, just to figure out where I go from here. That means if it's 2 over 1, I go up 2 over 1, up 2 over 1. And that is going to be my oblique asymptote straight out of there. So let me see if I can extend it this way here. Maybe not. That's okay. Maybe I can do it this way. Maybe. There we go. That'll work. Alright, I'll make that one a dotted line because it is an asymptote. Okay, and we're going to label this as my y equals 2x minus 1. Okay, so there is my vertical and oblique asymptote. Now let's move on to our intercepts. So my y-intercept is pretty easy to plot. I just plug in 0, and what do we get? So we're going to have 0 minus 0 plus 3 over at 0. Wait a minute, we can't have 0 in the denominator. Okay? So that means this has no solution. Well, no solution means no y-intercept. Next, we're going to take a look at our x-intercept. Okay, and that is simply where we take the top, 2x3 minus x squared plus 3, and set that equal to 0 and solve. Well, this is a degree 3. So I can try and factor this by grouping. I can tell you right now it's not going to work. So we are actually going to have to use polynomial long division again to factor this guy. Okay, so because there is a number in front of this x cubed, that means this is going to be a b over a situation. So to figure out those test values, we're going to use our b here. We're going to figure out all the possible factors of this. Well, what's pretty easy is just 1 and 3. And then our a value is 2. Again, pretty easy here. We can use these two, figure out all our possible test values that we can plug into here to make it equal to 0, and then use that to long divide. So 1 over 1, 1, 3 over 1, 3, 1 over 2, and 3 over 2. Okay, so we can plug in each of these, positive 1, see what we get. Negative 1, see what we get. Well, I'll start with positive 1. If I plug in positive 1 into here, let's see what happens. Well, I actually end up with 4. So that's not a factor. But what about if I try negative 1? Well, lucky for me, I do get 0, which means that x plus 1 is a factor. And I can divide x plus 1 out of this cleanly. So that is indeed what we're going to do. I'm going to take that x plus 1 from right here, and we're going to divide it out of this, not forgetting our placeholder. So 2x3 minus x squared plus 0x plus 3. And we are going to long divide. So I'm going to compare my x and my 2x cubed. So 2x cubed divided by x will leave me with 2x squared. Next step, multiply this by both terms here. 2x squared times x gives me 2x3. 2x squared times 1, 2x squared. And I subtract. And again, if I've done this correctly, this and this will cancel, which it does. So negative x squared minus another 2x squared leaves me with negative 3x squared. And then I bring my next one down. plus 0x. And I do it all again. So I will compare these two. So negative 3x squared divided by x leaves me with negative 3x, and multiply again. So negative 3x times x, negative 3x squared, which is good, negative 3x times 1 minus 3x. So when I go to subtract, again, these will cancel because when we subtract a negative, we're actually adding. So that cancels, but 0 subtracted negative 3 is just 0 plus 3. So that's going to leave me with 3x. And my last one to come down is this plus 3. And now we compare that one and that. So 3x divided by x just leaves me with plus 3. Okay, so now I'll multiply this 3 by both of those. 3x plus 3. And when I subtract, as I should expect, I get 0. No remainder. This divides cleanly. Okay, that means this is one factor. But now I need to use this whole thing up here to try and find my other two. Okay, so I can take this guy over here, take this all over here, and I now have to try and factor this down. Okay, well, I can try and use complex trinomial factoring, or I can try and use quadratic formula. And when I do use quadratic formula, let's see what happens here. Remember, that's my negative b plus or minus square root of b squared minus 4ac all over 2a. And with my a, b, and c here. Well, I want you to see what happens when I do that. When I plug in all those numbers into here, and I simplify, this actually turns into, it would have been a negative and a negative, making that a positive 3, plus or minus the square root. When I plugged in my b is negative 3, my a is 2, and my 3 is c, I actually found that I get a negative 15 under there. And then on the bottom here, 2 times a, which is also 2, which would have been 4. Well, I got a big problem here. I can't square root a negative. So, if that's not possible, that means this is not possible. So there is no solution here either. So that means I can't factor this. So if I can't factor this, that means this will not give me any x-intercepts because I can't factor it. But I've already figured out one. This is the only x-intercept that works. So this is a factor. So that means my only x-intercept is going to be at negative 1. Okay? That's my only x-intercept here is negative 1. So I'm going to plot that x-intercept at negative 1. And I'm going to plot my y-intercept. Oh, right, I don't have one because I've got an asymptote here, which makes sense. So the only time this function is going to cross an axis is right here, okay? Which makes sense because then that's probably going to look like this. Okay, so let's pop that in there. So this will look something like that. Okay, but if we're thinking of our like opposites, right? I would think that if this has to be the opposite side, it would be in here. But if I were to draw something in here, I'll do it for example, don't draw that, it crosses the x-axis, and I don't have another x-intercept here. So I can't have something there. So I don't know where my second piece is going to be. If it's not here, then maybe it's up in here, or maybe it's down in there. We haven't seen this yet. So let's maybe do a test value to see. Are we going to be in here, or maybe in here? So I know what's happening on this side, but let's maybe pick a number over here. And I'll pick 1. So I'm going to sub in 1 into this original function. And I'm going to see what number it spits out. Okay, maybe I'll be up here. I don't think I'll be in there. I already know at negative 1 I'm over here. All these numbers are covered, right? by this side of the asymptote. So I bet you I'm not going to be here, but if I don't have an x-intercept to be here, I bet you I'm going to be in here. So let's prove it. We're going to sub in 1 into our original function. And let's see what we get. So again, we're subbing it into this original guy here. So that's what we're doing right now. So, and I sub in 1 into here. Well, that's just going to be 2, right? Minus 1 plus 3 all over 1. Well, 2 minus 1 plus 3 gives me 4. And 4 over 1 is just 4. So my coordinate here is going to be 1 and 4, which again, 1, there we go, 1, 2, 3, 4, it's actually right here. So it again supports the idea that I have to be up here. So we haven't seen something like that yet. We've usually seen a diagonal, but that's why it's nice to double check. If we don't have another x-intercept, then we can't be living here. So we are, in fact, going to live in there, just like that. So now that we have this sketched, we can finish off with our behaviors. So I will give us a little break through there. I know we don't have a lot of room, but we'll do the behaviors right here. Okay, so let's talk about the end behaviors. So as x goes to positive infinity, as x goes positive, positive, what's happening? Well, our function is approaching our oblique asymptote, and I'll put it in brackets just so we can be clear. But we're coming at this oblique asymptote from above. Okay, but what about when we go? Sorry about that. There was an announcement. So as x goes to negative infinity, where is our function going? Well, as x gets more and more and more negative, you can see our green function here is approaching that oblique asymptote again. And we're coming at it also from above. All right, cool. Now what about around our vertical asymptote of 0? So as x approaches 0 from the left, our function is coming in this way as we're coming up in from the negative side. On the left, we are going up, up, up to positive infinity. Finally, we approach that from the right. We're coming in this way from the blue function here. My function is also going to positive infinity because we're going up, up, up that way. So that concludes all of our behaviors. We've got our vertical and horizontal asymptotes, our x-intercepts. We don't have a y-intercept, but we've got our behaviors. Here is our lovely sketch.